Hey, Kris. I think you're mute, Kris.
How's it going?
Ah, yes.
Yes.
Now we can hear you loud and clear. And we're doing well. How are
Yes,
you?
can you hear me?
Yes, we can.
Yes, also good. Very excited to be here.
Nice. Where are you at the moment?
Actually, I'm working from home now in the city of Middelburg.
Kijk, nice. Zealand. Okay. All
Yeah, it's
right.
a nice
So
area, but
yeah, probably also now dark at your place, right?
yeah, for sure.
All right. Well, Kris, first I will introduce you shortly. Well, Kris has a background in engineering, so he has worked as a structural engineer for quite some time, and now you are working for IDEA StatiCa, which is also one of the sponsors of the event. So thanks again for that. And and you're here to talk about BIM link flows related to IDEA Statica. So what's really nice, I think we have been cooperating with you for quite some time now. There's also an integration between our platforms,
Yes,
and
it's
what I
true.
can remember already for since quite some time, um, we're developing this integration with your package, and immediately also, we had some feature requests and those kind of things, and those were picked up really fast. So I think that's super nice to see that you're so flexible. And from my experience, I see that. That's well, you do of course a lot of stuff, but in the reinforced concrete sections, I have the feeling that more and more that you see that you are getting really to be the go-to software. So that's, I think, really cool to
Yeah,
see, and also that it's so easy to integrate, and that makes it, I think, just very valuable as well.
agreed.
Yeah. So yeah, we are really looking forward to your presentation, Kris. So feel
Yeah,
free to go ahead. And again, if you have any questions for Kris, ask them in the chat, and then we have time to ask everything. Hopefully, at the end of the presentation.
all right. Well, thanks for that introduction. Again, yeah, my name is Kris Riemens. I'm product engineer at IDEA StatiCa, and I'm very happy to welcome everyone to our presentation, which is about BIM link capabilities with IDEA StatiCa. In this presentation, I will first give a brief introduction about IDEA StatiCa, and then we'll dive a bit deeper into the so-called BIM links, where I discuss how you can obtain more efficient workflows. I will do this by showing you a couple of nice examples where we shall link IDEA StatiCa with external FEA and CAD models. And so I hope this can also help you to get more efficient workflows in your own projects. But first, a bit of introduction. So first of all, what is IDEA StatiCa? IDEA StatiCa is an engineering software solution for the structural design and calculation of steel connections, concrete sections and D regions, and critical members. In this presentation, the focus will be more on our solutions and workflows for steel connection design, but it is good to know that we also offer solutions for concrete. Furthermore, currently we have over 7,000 licenses in use worldwide. We have worked together with several universities like ETH Zurich and University of Prague to validate our solutions. We also have links with over 20 different external FEA and CAD software packages. And lastly, our company has over 100 employees, and we work together with more than 40 resellers worldwide, and we continue to grow as a company. As said before, the focus in this presentation is on our solutions and workflows for steel connection design. And to give a bit of background, what we see in the industry is that a majority of the structural defects are caused by bad design of particular joints or other details. And this, of course, leads to waste of money and time and waste of materials. Moreover, when we consider steel connection design, even though only 30% of connections designed can be considered as complex connections, they take up 70% of the time spent on connections designed. And therefore, there is a need for more efficient and fast calculation tools and also more efficient workflows. Often engineering companies already use some global FEA analysis software packages like ETABS or SIA Engineer for the global analysis of the structure, but they often lack capabilities to design the connections in more detail. And on the other hand, engineering companies also often use CAD software packages like Tekla or Revit to design more detail the connections, which can include also, all the stiffening plates and bolts, etc. But these programs then often cannot perform the structural calculation of these connections. So now, as IDEA StatiCa, we do not want to compete with these other software companies. Instead, we want to work together with them, and we want to facilitate efficient workflows where we can transfer data from one model to the other, so as to avoid repetitive work or making new models from scratch all the time. Therefore, we believe that IDEA StatiCa really can complement all these other programs and software packages that you, as an engineering company, might already have. So the main focus of IDEA StatiCa for steel is basically our connection application. This is basically the most used application for designing and checking of steel connections. And then to link our connection application with these other external software packages, that's where our checkbot application comes in. It acts as a sort of bridge between your external CAD or FEA model and the connection application. And so also we'll be focusing a lot on this application in the rest of the presentation. Coming back to our connection application, it offers several types of analyses. The most used is the stress strain analysis for performing strength calculations of your connection. But apart from that, it can also perform buckling analysis, stiffness analysis, fire analysis, seismic capacity design, if you're in an earthquake zone, design joint resistance, fatigue analysis, and horizontal tying analysis. Within our connection application, you can also access our connection library, which has also been upgraded recently to obtain hundreds of predefined connection templates, which you can still further adapt as you wish. And recently we made this connection library also available online. So in the browser, you can just find hundreds of predefined templates and download them and use them in your design. To design your connection in the connection application, we offer many different so-called operations. These operations to modify the connection in IDEA StatiCa mimic the real manufacturing operations actually. You can either start with a predefined template or start from scratch. And by using these operations, one can keep editing the connection to achieve any design in minutes. A little bit of background information on the method that IDEA StatiCa uses to perform the analysis, and also contrasting it to the more classical approach, so-called component method. IDEA StatiCa uses what we call the component-based finite element method. What does it mean? It means that in IDEA StatiCa, you still model the connection with all its components like bolts and welds and stiffening plates, etc. But now these will be converted into a finite element model. So all the plates will be modeled with these shell elements. We also have special elements for welds and for bolts. And whereas with the classical components method, you can be quite limited in the topology that you want to calculate with all these complicated formulas. With the CBFEM method in IDEA StatiCa, we can model any topology that we want. We can take into account complex configurations, shapes, openings, etc., and obtain more accurate results. And therefore, we can also obtain a more optimal design compared to these traditional methods and save a lot of material. For more information about the technical details, I refer you to the theoretical backgrounds on our website. It also includes many tutorials, webinars, knowledge-based articles, etc. if you are interested. So let's now talk a bit more about BIM Links. As mentioned before, we see often that engineering companies already use some FEA software package to perform global analysis on the structure, but which does not always allow you to design or calculate the connections. What our BIM link for external FEA model does is to basically import the geometry of the main members of the structure or the connection and the internal forces coming from the global analysis. And in IDEA StatiCa, you just have to add then the design of the connection and you're ready to calculate the connection. On the other hand, when you start with a CAD model where the connection has already been designed with all its bolts and welds and stiffening plates, etc., we can now import that full design of that model into IDEA StatiCa. We still have to add the loads then, but after that you are ready again to calculate and code check your connection. Here you can see an overview of all the external FEA and CAD packages like SIA, AXIS-VM, Tekla, Revit, etc., that we have BIM links with. And yeah, you can also see the list continues to grow. In this slide, you see a bit more detailed overview of the workflow with external FEA model. So you start with global analysis in your external FEM software. And then the basic idea is to export the model or part of the model into the checkbot application. And within the checkbot application, you can choose your specific nodes or connections, which you then can further open into the connection application. In the connection application, we can add the design. We add the stiffening plates, the bolts, etc. And finally, we can perform the code check on your connection. If you make some changes into your global FEA model, we can synchronize those changes into IDEA StatiCa. Here we see an overview of the workflow with an external CAD model. It's quite similar to the previous one, but in this case, we export part of the model or the whole model into the checkbot application again. But now when we choose specific nodes or connections to be further exported into the connection application, we now see that the stiffening plates and bolts, welds, etc., they are already there coming from the CAD model. But in this case, we just have to add the loads to the model. After that, the model again is ready for code checking and calculation. So I want to demonstrate how this works with a nice small example. So as you can see, I have here a model, in this case in SIA Engineer. It's of a very simple steel frame. I have some load cases, and you can also see it's a calculated model because I can visualize the internal forces if I want to. Here are the bending moment lines. And now let's say that I want to use this information to send to IDEA StatiCa. What is then the procedure? I simply go here to Design, External Tools, and I click on IDEA StatiCa, and it will automatically open the checkbot application. It can take a few seconds. Yeah, it's opened on my other screen. And when the checkbot model has opened, you'll see in the right bottom corner, it has established a link with SIA Engineer. You do not yet see any part that has been imported. To do that, I simply select a specific part that I want. So let's say I want to focus on this connection here. I click on Import Connections. And what the program will do is it will convert the information to a SAF model, and it will import it into the checkbot application. So here we see part of the model that I selected. We have the column and the horizontal beam. And you also see that basically two nodes have been recognized as connections. Not only the connection with the beam and the column, but also the support of the column is also recognized as a separate connection. In the checkbot application, I have some options to check also whether all the load cases have been exported properly. And then I can also visualize the internal forces if I want to. Those should match up with the internal forces from the SIA model. If that's all fine, I can choose a specific node to export into the connection application, and I simply click here on Open. And now this can take also a couple of seconds, so you do have to be a little bit patient. And the idea is that when this specific node is exported into the connection application, that now the members, so the geometry of the profiles of the column and the beam, are already there, as you can see, and also the internal forces are here. So you do not have to calculate them separately by hand. They all come from your global FEA model. The only thing I still have to do is add the design. And to do that, I can make use of these operations. So let's say I'll choose a end plate operation. I can use some specific bolts. There we go. I can add some stiffener plates if I want to. This all works very intuitively. And then basically, if I like the design, I can calculate it. It's going to calculate the design with the two load combinations that have been imported into it. When I'm happy with the design, you see that basically the strength checks all are okay. There's just one detailing checks related to the bolts that is not okay. So I can still change the design if I want to, but suppose I'm happy with it, I simply click here on save, and I can close this. And you'll see that the design has been sent back to the checkbot application. The design will not be visualized in the 3D model, but if you click on the design, you can see the design more clearly here on the right menu. And this is basically the procedure to then continue on with the next connections. Suppose I have a change in my model that, for example, this column here, I want to increase the size of it. So let's say I want to change it to this bigger profile, HEA 300. I can simply update it very easy by clicking on the synchronize button. And you'll see that the column has increased in size and the profile has changed now. So this was just a quick example of how the BIM Links works with an external FEA model. And of course, what you could also do is perform a stiffness analysis, for example, and check whether what is the classification of the joint, if it's a fully rigid or a hinged or a semi-rigid joint, and you can check what's the rotational stiffness. You can import it back into the SIA model if you want to, but because of time, I'm going to continue on with my next example, which is now a BIM Links with an external CAD model. So I have here a TECLA model. Again, it's of a steel frame. And let's say I want to focus on this joint here. I'm going to click again on the checkbot application, the plugin. You have to install it. The checkbot application will automatically be opened. You see nothing specific has been imported yet. I can click here on the so-called bulk selection method. It will send me back to the TECLA model, and I can simply drag now a specific connection, including all the stiffening plates and bolts, etc., and import it back into the checkbot application. In this case, it's going to send the geometry of the main members, but also the design of the connection, so also all the stiffening plates, etc. You won't be able to visualize it here in the 3D model, but if you open this specific connection again with this button here into the connection application, you should see that the full connection is there, including all the bolts, all the stiffening plates, and all the welds, etc., etc. You'll see how IDEA StatiCa has converted all the information into specific operations. So this is a very fast, efficient way of creating your connections. You don't have to manually perform all these operations anymore if you have this TECLA model ready. The only thing you still have to do is add loads, right? So I create new load effect. I can put some loads on it. For example, here, some shear force. And I can run the analysis. Once the analysis is done, you can see I have all green checks, so everything is fine. Of course, you should go through all the specific results in more detail, check out the stresses in the plates, the results of the bolts, and of course also the results of the welds, etc. Again, if I'm happy with it, I can just save it and close this off. And then the idea would be to just keep on importing more and more parts of the model into the checkbot application, and then exporting from the checkbot application into the connection application. If a connection has been calculated and all the checks have been valid, been verified, you will also see this green check here. It means that that connection has been fully checked and calculated. All right, moving on then with my final example. It's also quite interesting one actually. And this is actually where you have a Tekla model and a SIA model, a COD model and a global FEA model together. And the nice thing is that you can actually use the information of both models to merge them together, so to say, into IDEA StatiCa. So from the Tekla model, we get a model including the design of the connection, and from your global FEA model, we get basically the internal forces on the connection. And the idea is that we combine this information into one model in IDEA StatiCa. So what I have here, I have a SIA model as well from the previous model that I showed in Tekla. And let's say I also want to focus on this connection here, right? So again, I simply use the checkbot application by clicking on the plugin. The checkbot application opens. And it's going to import now the same connection, but in this case, it will import the connection with the internal forces and without the design of the connection itself. So the idea would basically be to consider this connection here. And instead of opening it here in the connection application, I'm going to export it as a separate file. Here. And then we can basically open it in the connection application. I have it here. So then basically we have one IDEA StatiCa model that includes all the forces, but not the design of the connection. And we have one model here that includes the design, but not the internal forces, right? And so what we can do now is say, let's take this model with the design, and we can use this option here, connection import. And we'll choose this exported model from SIA. And it simply will copy the loads from this model into the model that's from Tekla. So in this case, I don't have to calculate the forces by hand. I don't have to model anything. It's all merged here in one model, and I can calculate it. And if I'm happy, then I can move on to the next connection. Due to time, I won't wait till the calculation has finished, but I hope the principle is clear. And that was basically the end of the presentation. Thank you.
Well, Kris, we were like mind blown with Stijn here. Yes, it's super nice to see what you can do, and it was so nice that it almost hurt a bit and not because of you, of course, but because of a personal story we have with Stijn. So one of the first projects we did as engineers was actually doing what you shown. So it was like top structures on FPSOs. FPSOs are like floating processing facilities for oil extraction. You have a lot of top sides on top, and then we had to make a global model, extract all the loads from each like intersection, then make a smaller model because otherwise it will get too heavy, and all what you have automated by hand, and it was such a pain, such a pain. We would really have loved to have this 10 years ago. But on the other side, if we had this, maybe we'll never go into automation and have built it VIKTOR. So maybe it pushes us to automate stuff. But it's super great to see what is possible nowadays with this kind of software. Really amazing.
Yeah, for sure. You can save so much time with these efficient BIM links. It's unbelievable.
Yeah. And there's some questions from the public, eh? And I think you kind of really answered a few of them. But for example, the connections library, is this something you can just download and import in your model? How does it work?
Maybe it would be nice if I could still show you briefly. So if I can share my screen again. So the connection library, it is available now online on our in the browser. You can just go to it. It's connectionlibrary.ideastatica.com. And what we're trying to do here basically is to create a whole database of predefined connections, right? So you can fill in your desired typology and just press search, and it will go through a whole database of predefined connections. It also has some filtering options. So if you say, I only want bolted connections, it will filter out all the welded connections, etc. Or if you say, I only want welded connections, it can do that as well. And here you can add additional members, etc. and change the topology if you want. Again, also, you can download these connections and open them in your connection application, and you can still make adjustments to them and change them if you want to. So that is the connection library.
Okay, that's cool. And the next question is, can you group similar connections so you can check them together? And I think the question is related to the fact that you want some kind of standardization inside your designs. So some connections that are kind of similar, you want to treat it in the same way, not?
Yeah, it's a good question, because you might have a global, a structural global model that involves many of the same connections. And you don't want to model the same connections multiple times, of course. So we do have options there as well to simply say the same design should be applied on different nodes. It's just that we cannot simply assume that you just have to calculate them at one spot, because it might be the case that the connection at a different location has different internal forces, and you do have to check all the different combinations and forces on each position, even if the connection is the same on those positions. We do have an option that might reduce some of the work. So if you have many different load combinations, load effects, there's an option here to calculate the load extremes, and it will filter out some of the combinations. But we recommend to be a bit careful with that, because this algorithm, it looks at load combinations with maximum values, so maximum normal force, maximum bending moments, etc. But it's not so clear that you always filter out non-critical combinations that way, right? So for the final calculation, it's still recommended to calculate all the relevant load combinations in that way.
Cool. And we're out of time, but maybe we have a short yes or no question. Can IDEA StatiCa also export as EFC?
Yes, that's actually just recently been added, so that's quite a nice feature. But it's possible. So let's say we have this connection here. we simply go here to the report tab, and there's an IFC export button.
Yeah, you're
And,
not showing it on the screen now, Chris.
oh,
but
I
I
thought-
think.
Yeah, I
Yeah,
thought I
right.
was still sharing my screen.
Yeah.
But it's the short answer is yes, it's possible.
Cool.
Well, thanks a lot, Chris. I
Yeah,
think I
you're very welcome.
really like the work that you are doing. So I think this can be very valuable. So hopefully you inspired quite some structure engineers with this, and that you can help them out in this way.
Yes, it was a pleasure to be here. Thank you.
Thanks a lot.
Thanks,
Have a
Chris.
good evening.
Bye bye.
Yep.
Bye bye, Chris.